All right, guys, so we're going to pick up and simplify radicals. We're going to simplify some radicals here. Now, what we've previously done was to simplify square roots, just square roots with no variables. So something like, the square root of 20, we simplified, said that that is the square root of 4 times 5, and then we can take out the square root of 4 as 2, and that gave us 2 square roots of 5. Well, the only thing we really did was this being a square root, that power is only 2, that root is only a 2, and we only had the numbers in here, no variables. Well, now we're going to deal with having the variables inside and higher order roots other than 2. Let's start off with the square root, but this time you can see we have some variables in here. We have x and y to the third. Well, the good news is that the square root of the 24, that we're going to do the same way that we did over here. So what I like to do with my students is I just tell them to draw a line this way, and what we're going to put here is everything that's going to come out of the radical. And then over here, we're going to put whatever's staying inside the radical. You can even put another radical here. So what we take out is going to go here, and then what's going to stay inside is going to be in here. So let's look at the square root of 24, and we can do this over to the side. So we can say square root of 24, and we know from previously working on simplifying square roots that we can say that's equal to the square root of 4 times 6, which is 2 square roots of 6. So that means the 2 comes outside and the 6 stays. So I'm going to put the 2 here, that comes out, and the 6 is going to stay. So that part is complete. Now, when it comes to the variables, got an easy way to deal with this. You know that with a square root, that's a 2. That's what the square root means. We don't write it. We only write the higher orders like the third root, the fourth root, and so on. But square root, we don't write it, but you know it's a 2. And we know that this exponent is a 1, even though it's not written. All right, here's an easy way to do this. Say to yourself, does 2 go into 1? Does 2 go into 1? And it does not. You need to have at least the same number. It needs to be at least a 2 to go into it at least one time. So 2 does not go into 1. That means that x has to stay inside. We cannot take anything out of it. It's got to stay inside. Then we say, all right, does 2 go into 3? And it does. It goes in one time. So we're going to take out y to the first power because 2 goes into 3 one time. Well, what does that leave us? So if 2 goes into 3, we take out the 2 of them. How many does that leave? That leaves the 1y here. And here's the 1 for the x's to show you. So again, 2 goes into 3 one time. So we took that out one time. And then what's left over is just 1. So this is what's coming out. This is what's staying inside. So you can do your square root. Just basically put that back over here together. So 6xy. I really don't need to put the 1s for the exponents. We know it's implied. So the actual complete answer will be 2y square root 6xy. So that's just how I like to set the problem up, by taking out what's over here and leaving what's inside in the square root. All right, let's look at another one. So you can see here, now we have the third root. So that's going to change everything up here. So a lot of times students they forget about this. So used to doing square roots that they just treat this problem as the square root as opposed to the cube root. So you need to either highlight, do something so you remind yourself that this is the cube root. So this is what's going to come out. It's going to come over here, and that's what's going to stay. So let's look at the cube root of 16 by itself. Now remember, we're going to break this up into a multiplication, but one of the numbers has to be a perfect cube. Well, what are the perfect cubes? If you have 2 to the third, that's 8. 3 to the third is 27. Well, that's definitely too large. So it's either got to be 8 or it's not going to be anything. That means it can't be reduced. And we can say that this is equal to the cube root of 8 times 2. And then we just said that the cube root of 8 is 2. So 2 cube roots of 2. So the cube root of 8, this comes out as 2, and then the 2 stays. So the 2 comes out, and 2 stays. And let me put the cube root there so I don't forget. So now let's go to the exponents, the variables. And we're going to do the same process I did before. 3 goes into 3 one time. So that means I can take out 1x. Is there any remainder? No, it goes in one time and there's no remainder, so the whole thing is gone. There's nothing that's staying inside. Then we say 3 goes into 2. It does not go into 2. Because again, the smallest this number can be is a 3. It has to go in at least one time. If it doesn't, it's all got to stay inside. So this whole thing has to stay in, nothing comes out. So then this would be cube root of 2y squared. Remember that, we're just bringing it up over here. So the answer is 2x cube root of 2y squared. And don't forget to put that cube there. If you don't put the third root there, then it's implied that it's square root, and that's not the same thing. All right, let's look at another problem here. So now we have a number in front already, which is multiplication, and it's a square root, so you're a little more comfortable with that. So we're going to, this is what's coming out. Now I'm automatically going to put this 6 and a times symbol, because whatever comes out of here, whatever we take out, it's got to multiply by the 6. So I'm already going to put that. I'm going to put that right there, getting ready for it. And then whatever's going to stay is going to be here. So we can look at the square root of 48, and we would say that that is 16 times 3, because the square root of 16 is 4, and that's the largest perfect square that we can break this up into multiplication. So this is 4 square roots of 3. So that means the 4 comes out and the 3 stays. So 4 comes out and the 3 stays, and that's done. Now we know that this is a 2. So we say, how many times does 2 go into 5? It goes in twice. It goes in twice. So that means that we can take out an x squared. That's where the 2 comes from, the twice. 2 goes into 5 twice, comes out. What's the remainder? Well, it goes in twice, and that would be x to the 4th, so there'd be 1 left over here. So 2 goes into 5 2 times, and there's 1 left over, a remainder of 1. 2 goes into 4 2 times, and clearly there's no remainder there. And then 2 goes into 3 once, so take out a z here, and there'll be a remainder of 1, so that has to stay inside 1z. So then this, put that over here, so 3xz. So then the final answer, let me just fix this up here. We're going to multiply those two numbers, because remember we still have to multiply to 6 here. So we get 24x squared y squared z square roots of 3xz. And that is the answer for number 3. So let's take a look at this one here. So now we got the 4th root. So again, I'll just do a little highlighting there. So this is going to stay inside the 4th root, and then we're going to start what's going to come out here. So take a look at the 4th root of 16. And if you take 2 to the 4th power, that is actually equal to 16. So that means that this is a perfect 4th root, which is 2. So that means the 2 comes out and nothing is staying, it's gone. The 4th root of 16 is 2, the whole thing comes out. All right, then we say how many times does 4 go into 5? It goes in once, and there'll be 1 remainder. There's 1 left over. Then we say how many times does 4 go into 12, which is 3 times, so y to the 3rd comes out, and there's no remainder. There's no remainder, so the whole thing comes out. So the only thing that's staying is this, the 4th root of x to the 1st. So then we can just say 2xy to the 3rd, 4th root of x is our answer. All right, got one more. Try this one here. This time we have a number in front again, it's multiplication. So I'm going to go ahead and do 4 times, knowing that we're going to multiply whatever we take out times 4. And then this is going to be our 3rd root, whatever's staying. So we're going to deal with the cube root of 54. So if you do 2 to the 3rd, that's 8. 3 to the 3rd is 27. And I could pretty much stop there, because if you do 4 to the third, that's going to be 64. And it's already a larger number. But I can see that this right here is going to break up into 27 times 2. That gives us 54. So then that means this would be, the cube root of 27 is 3, so it's going to be 3 cube roots of 2. So the 3 comes out, and the 2 is staying. All right, that takes care of this here. So then we do the root here, the 3. So how many times does 3 go into 8? Goes in twice, so that's x squared. And what's the remainder? The remainder is 2. So that's going to stay in there, because 3 times 2 is 6, right? So then 8 minus 6 is 2. The remainder is 2. So 3 goes into 8 twice. That comes out, and there's 2 left over. Then we say how many times does 3 go into 10? 3 goes into 10 3 times, so y to the third comes out, and the remainder is 1. So that is going to be over here, cube root 2x squared y. And now we're going to multiply the 4 times 3, so the final answer is going to be 12, and then x squared y to the third, cube root of 2x squared y. All right, so hopefully this helps you with simplifying radicals. And what I'm going to do in the next video is we're actually going to do operations with radicals.